All right, this week in Moodle, we have your chapter 3 test. All right, we've got your chapter 3 test. And I wanted to go over a couple problems that I didn't do on Piecewise that are going to be on the test. And then we need to cover 4.2 through 4.5 by next Tuesday. So I did for 4.2, it's pretty much just line of best fit. I'm going to pull up Desmos and go over that with y'all on Desmos. It's pretty easy. And then 4.3, which we'll cover today, hopefully, is on quadratics. And then next week on Tuesday, we'll cover 4.4 and 4.5. But chapter 3 test, and I will say for the final algebra, I did not count that as a grade. So that's just kind of, I moved, like in my grade book setup, your tests are like, your quizzes and stuff are 60, I believe. Homework and quizzes are 60, and there's a lot of those, right? And then your tests are 20, and then your final exam is 20. So then I kind of put that not in the grade book part. You can see it up there, but it's just not graded in that section. It doesn't count. I will say next week, your reading assignment is going to be posted. And your reading assignment is just going to be a 1 to 2 page paper on a mathematician. Yeah, and that'll be an extra good test grade that can bring up your test at grade averages if they're not great. Most of you guys are doing fine on your test grades. But anyway, so this week you have 2 quizzes and a test due, just to let y'all know. All right, so I'm going to stop sharing the screen, and I wanted to go over a few problems with you guys that you're going to see on the test and Piecewise. If I do the chat. Okay, Casey's still not there though, right? Or else I would see him here. Okay, so if on your test, you're going to see a few problems where I give you like a piecewise, and let's say it's like 2x plus 1 if x is less than 0, 2 if x is equal to 0, and then 3x plus, or let's say x squared plus 1 if x is greater than 0, okay? And I give you guys, then I want you to find f of -1. Like this is an example of what's going to be on your test, okay? Does anybody have any idea how I would do this? We did go over this and I wanted to, so I forgot about it. Anybody know, I have any idea how we would find this? How would I find f of -1 on this?
Replace all of the x's with -1.
But would I replace all of them?
Well, not all of them, but the x's in the equations given.
Okay, but technically, like we're looking at, this means what? X equals -1, right?
Yeah.
When it says f of -1, then x is equal to -1. So is there a particular equation that goes with -1 as x? Because remember, these are your domain restrictions. Okay, so Jackson said, and then Jelly said, in this case, you're going to have to look at the first one. Why did we look at the first one? Because Jolie said x is less than 0. So look at our restrictions, right? This one says x is less than 0. This one will be x is equal to 0, and this will be x greater than 0. So we're going to have to go with the first equation because we know that -1 is less than 0.
So we're not required to solve.
So we're not required to use these two. You're only going to plug it in this one. Okay, everybody good at NERSA? So again, this is what you're going to do on your test because there's several problems like this. So we're going to plug it in the first one. 2 times -1 plus 1 is going to be equal to -2 plus 1, which equals -1. Got it? So you would say f of -1 is equal to -1. Now, if I said find f of 3, which one would that be? Good, because
X is greater than 0.
because 3 is greater than 0. Yeah. Okay, So f of 3, we know 3, this means x is equal to 3. We know 3 is greater than 0. So you would do 3 squared plus 1. You're going to look at that equation, and this will be 9 plus 1 equals 10. Now, what if I asked you f of 0? It would be the middle one. So what would be the answer?
Zero.
Would 0 be the answer?
Well, no.
It's okay. Caleb said 2. Yes, it would be 2. Because this means x is equal to 0, right? And this means it's equal to 2. So y, or our f of 0, would be 2. Okay? Questions on this? Anybody have questions? Do I ever need to do one more of these? I'll do one more. I can't come up with it from the sections of chapter 3, piecewise, which was 3.4. I'll make sure everybody gets this down, then I'll do another example. And then we'll move on. I'm going to show you guys, I'm going to do 4.2. I'm going to do line of best fit on those Desmos with y'all. And then we'll do 4.3. They got it? Um, Okay. And I want to find f of 0, f of -1, f of 3. Okay, you guys do that one for me. Okay, so we've got 2x minus 4 when x is less than equal to 2, but greater than equal to -1. And then you've got x cubed minus 2 when x is less than equal to 3, but greater than 2. All right, we ready? All right, so which one am I gonna look at for f of 0? First one? Okay, top one, yes. Why the top one? Because this is saying numbers that are less than equal to 2, but greater than equal to -1. So that would be -1, 0, 1, 2 would fall in that category, right? So you would plug in a 0 to the top equation. 2 times 0 is 0. 0 minus 4 is equal to -4. Everybody get -4? All right, -1. Which one are we gonna look at for that one? Top one again. You're gonna do 2 times -1 minus 4. 2 times -1 is -2 minus 4 is equal to -6. Did I get that? All right, what about the last one? F is 3. Second equation, bottom one, last one, good. Because we're looking at numbers between 2 and 3, you can include the 3 here. So you would do 3 cubed minus 3, that's what, 9. 3 times 3 is 9. 9 times 3 is 27. 27 minus 3 is 24. Did I get 24? Am I good on this? Questions?
It's 6 cubed minus 2.
It is. You are correct. I'm saying that. Okay, so it should be 25. Woo. Sorry, guys. I'm just seeing if y'all are paying attention. It's all. All right. So yeah, it should be 3 cubed minus 2, which is 25. All right. Everybody good? All right. Moving on to chapter 4. Chapter 4, 4.1 is going back over linear models. We have done linear already. So I'm not going to really spend any time on it. You can take a look at it. But it's just going back over property of linear functions and linear models. We know a linear function is y equals mx plus b, right? We know the slope, we know the y-intercept, we've gone over that. So I'm not going to spend any time going over it. 4.2 is going over how to find the line of best fit of a linear model. And so all I'm going to go over for you guys on that is just how to do this on Desmos. You can create a scatter plot on Desmos and then actually find the line of best fit. You can also do this in the graphing calculator, and I believe there is a video of that in Moodle. Let's share screen. If you see here 4.2, there's a 4.2 folder notes right here. And there's a video here going, if you have a graphing calculator, you can use this to find it. Okay, so I'm not gonna go over that one, but I do want to do Desmos with y'all. And I didn't know how to do it, but I looked it up today. So let's hope I can remember what to do. Can everybody see this? Okay. All right, so to do this, we have to first go to our table, and we want a table of values. I'm going to go to table here, and we're going to input our values. So I'm going to do, just going to pick one to do. Let's do 3, enter, 4, enter, 5, enter, 6, enter, 7, 8, 9. Okay. And then we're going to get rid of that one. And then on this side, I'm going to do 4, 6, 7, 10, 12, 14, 16. Okay. And you can see it over here. Here it is. Okay. I can zoom out a little bit. There it is. Now it looks to be linear, right? Our scatter plot looks to be linear. And normally, does anybody know? Now, does anybody know how you would find the line? How would you find the equation if you didn't have a graph calculator? Does anybody know? How do we find the equation of a line? Can I see the chat box up here? Okay, I can't really see it. All right, so if I was to do this by hand, what you would normally do is just randomly pick 2 of these points and find the slope and find the y-intercept and find the equation of the line. And it would look, maybe if you pick these 2 points, it would kind of go through here, right? It would not be very accurate, but if you do on the calculator, it'll actually find an estimate of the line of best fit. So to do that, we're gonna go in this second column. And so notice how it has the X1 and a Y1 here. You're gonna want to represent those on your equation. So you're gonna do Y and then 1, and it automatically brings that down to a subscript. And you're gonna do the little squiggly, the approximation. Now, do I have that up here? Little squiggly. But here, and I want the little squiggly here. You'll see it?
I have it, it's on the top over the tab button.
Oh, okay. Oh, I see it now. Yeah. So you have to use this because that means approximate, right? It's not the exact. So they want you to do approximate. And then you're going to type in the equation y equals mx plus b. So you're going to do m, and then you're going to do x1, because we're using that, plus b. And so if you notice right here, this is called your correlation coefficient. And what that R value tells you is how accurate this is. So this means it's 99.65% accurate. It's pretty close, right? If you look at the black line, it goes over it. So it's pretty much covering everything but this little outlier right here, okay? And notice they give you a value for M and they give you a value for V. And now what you can do is you can type this equation in, y equals 2.03571x minus 2.35714. And notice how it goes right over that line that they gave us. And so that's how you find the line of best fit. It's pretty easy, right? You can also do this for quadratics. You could do this for polynomials. It'll find the line of quadratic line of best fit. So yeah, pretty easy. Are there any questions? The main thing is remembering you need to put y1, the approximate, and then the x1. So write that down if you haven't written that down. The other thing to write down is R is equal to the correlation coefficient. I'll write that up here on the board if you guys need me to. Correlation coefficient. That's what the R value is. R value. And this tells you how well the line of best fit fits the data. So again, you want the closer to 1 or -1 is better. Like if it was like 0.65, it's not a very great line. Does that make sense? If it was 0.5, really not a great one, because that's only like 50% accurate. I know you guys can't see this, so I will,
No, we can. So it's weird with us because we can see your shared screen and we can see the.
oh, okay, that's good.
It's
So you
just
can
you
still,
that can't see us.
okay, well, good. So you can still see me a little, but-
Yeah.
So again, I would write this down, write down when you're putting in Desmos specifically, write down that Y1 squiggly, M times X1 plus P. That's how you would do the line of best fit. And again, you're gonna plug your data values in the table. Okay, and that's pretty much all of 4.2. Pretty easy, right? Anybody have a question? Can't see, that's the only thing I can't see is the chat box.
I got you, but nobody's saying.
Nobody said anything, okay. All right, so now we are going to do 4.3, which is going back over quadratics. We talked about quadratics, but we haven't gone over how to actually graph quadratic by hand. And so I do want to go over that with you guys. And then that's pretty much all 4.3, I think. Yeah. We've gone over like quadratic formula, how to find the solutions of quadratic, all that kind of stuff, but not actually how to graph it. So everybody's got this down?
Hold on, wait a second, let me check.
What's the 25 supposed to be?
No.
No, okay. Oh, wait a minute. So again, this is 4.2. It's going over line of best fit. And correlation coefficient is your R value, tells you how well the line of best fit fits the data. So again, you want this value to be closer to 1 or -1, and it's gonna be between those values anyway. But again, if it's 0.5, if R is equal to 0.5, that means it's not a great line of best fit, not a great prediction, estimation of best fit. If it's 0.99, that is a great estimate of line of best fit. And that means, what that means is it's like about 99% accurate. That's what that means. Am I recording? I was. Oh my gosh. Okay, no, I'm still recording. I was getting worried there. Yes, I'm recording. Everybody got it? Okay. Yes? Everybody good? All right, so 4.3 is going back over how to graph a quadratic by hand. Quadratic functions. This is the standard. All right, so this is the standard form of a quadratic. Have we done that before? Have we gone over that before? Yes, because remember we had to do the quadratic formula and you had to pick it from that, right?
Yeah.
So this information can also tell you some information about your parabola. Remember, a quadratic can look like this, or it can look like this, right? This is called a minimum. And this is called a maximum. And the way that you determine which way it opens, up or down, is by the value of A here. Okay, so if A is positive, meaning it's greater than 0, it's positive, which way do you think it's going to open up? Which way do you think it's going to open? I know. It's going to open up. All right, if negative A is less than 0, it's going to open down. Opening up means the minimum. And opening down means the max. Okay, so depending on what this value is, if it's a positive, it is going to open up. And if it's a negative, it's going to open down. If it's positive, means it's going to be a minimum. If it's negative, it's going to be a maximum. Everybody should be moving their pencils, writing this down.
Didn't you say?
What?
Didn't you say for them?
Yeah, it's okay. I'm just not gonna worry about it right now. I don't love having my camera on at meetings either, but I do. Most of the time, unless it's like no one I know who it is. All right, the next thing we're going to talk about is, well, what is this point called? Do we remember this? Here and here. I can't talk about it either. What is that point? Yes, Chance, it's called the vertex. And so in the vertex, there's actually this invisible line that cuts your parabola in half. Does anybody remember what that invisible line's called? I think we've done this either. If I remember that visible line's called, it's called the axis of symmetry. So there's actually an equation that we can find, and the axis of symmetry is going to be, so think about your vertex, it's like your x, y, right? Your axis of symmetry is the x value of the vertex. It's like a vertical line. So axis of symmetry is going to be the x value of your vertex. It's a line. It cuts your parabola in half, cuts parabola in half. Okay, think about symmetry, right? Think about cutting a line on your face, right? You could cut right in the middle, you have your eyes or whatever. We're not completely symmetrical, but for the most part. All right, there's a formula for it. It's going to be x equals negative b over 2a. That is the formula that you're going to use to find the x value of the vertex, okay? And then what happens is you can take that x value and plug it back into the equation, and you'll get the y value, and then that gives you your vertex. I'm going to do an example of all this in just a minute. Okay, so it gives you the x value of your vertex. Your vertex is the point on your parabola where you get the highest point or the lowest point. So vertex is the highest or lowest point on parabola. All right, and then the last thing I want to talk about here for the graph, does anybody know what the C value represents? What does the C value tell us? Anybody know? Anybody? Where it goes to the y-axis? Yes, what's that called? Good, guys, look at y'all. Y'all are so smart. All right, it's the y-intercept. Why is it the y-intercept? Well, what is a y-intercept? Remember, I told you guys to remember this? What does it mean when there's a y-intercept? What is what? Y-intercept means x is 0. Thank you. All right. So our y-intercept, imagine if you plug, no matter what these numbers are, right? If you plug a 0 here and here, what are you going to be left with? C. So that's why it's the y-intercept. So C value is the y-intercept, which means x is 0. Okay? So that's something else. You can just look at it and tell what the y-intercept is immediately. Because if I plug 0 in for the x's, you're going to be left with the C value, the constant. We would say constant doesn't have a variable beside it. All right. Let's do an example of this. There also is another form I want to show you, the vertex form, but we'll do that one in a minute. Everybody got this down? I am recording this, so. All right, we got a lot here, when it's fine. Oh,
She says she's trying to walking in, but the door shut. You just needed to knock.
well, she just should have just knocked. Hey, you should have just knocked, because we're in here. I just shut the door because I'm loud and people walk by. Okay, so we want to look at which way it opens. Tell me, is it a max or min? Tell me the y-intercept, axis symmetry, vertex, x-intercepts. And we've gone over x-intercepts. That was what we did earlier.
I'm checking.
Okay, she might went to the library. Right there. All right, so,
In the library.
okay, well, it's fine. Tell her to just stay in there. It's okay. We only got about 20 minutes left.
She can hear you.
Yeah, okay, I forget that. You're like texting her and I'm talking to her. If you want to stay in there, you're fine to stay in there. Or if you want to come down here, you're welcome to come in here too, whatever you want to do. All right, which way does it open? Can anybody tell me which way it opens? Up. How do we know it's up? We know it's up because this is our A value, 2 is our A value, it's positive, so it's going to open up. Okay, which means, is it a max or min? If it opens up, it's going to be a minimum. Good, so I'm gonna put a min. All right, what else can you tell me? Can you tell me the y-intercept? What is the y-intercept? 5. Again, it's this B value. So already from this information, I know that it's gonna cross here, and it's either gonna look like, well, we don't know where the vertex is yet, but it's gonna look like this, or it's gonna look like this, or it could go down lower, go down higher versus, okay, but it's gonna look like that, something like that. All right, now we want to find the axis of symmetry. So I'm gonna write AOS for that. And remember your formula is x equals negative b over 2a. So how do I find that? Well, this is your A value. So 2 is our A, B is 8, C is 5. So negative B means the opposite of B. So B is 8 here. You're going to plug in negative 8. 2 times A value is 2. So this is going to be negative 8 over 4, which equals a negative 2. So that means we know that our vertex is going to end up being this way. It's going to be somewhere along here. It's going to be somewhere down here. Okay. Somewhere from here down. Now, how do we find the rest of our vertex? We've got the x value. How do I find the y value? How do I find the vertex? Mentioned this. I didn't write it down, but I mentioned it. Anybody know? I've got the x value. How do we find the y value? Oh, we use our equation. We've got the x value. F of x means what? The y value, right? So I'm going to do y equals 2 times negative 2 squared plus 8 times negative 2 plus 5. Does that make sense? Now we're going to solve for y. Negative 2 squared, yes, Chance. Negative 2 squared is 4. 4 times 2 is 8. Plus negative 16 plus 5. That's going to give you a negative 8 plus 5 equals a negative 3. So our vertex is going to be negative 2, negative 3. So negative 2. So here it is. Looks something like that. Isn't that amazing? You can just find all that by just looking at it. I mean, we had to do a little bit of math, but. All right, I have one last thing to do. I have to find the x-intercepts. So we know they're going to look like this, probably. It looks like it's between -1 and -2 and possibly This is probably -3, -4 probably. I had to guess, but we can actually find them. Do we know how to find them? Do you guys remember? It's what we did in chapter, it's what we did in the review in chapter 1. How do we find the x-intercepts? Set equal to 0, okay? So we got equal to 0, good, because we're solving this, right? And how do we solve this? Well, we've learned some multiple things, haven't we? What are the things we've learned? Factoring. Well, factoring is the box, okay? What else? You could complete the square, I told you I never use that way, so don't do it that way. Or the square root method, we're not gonna do the square root method on that one, but there was one more that works for all problems. Yes, Chance, quadratic formula. So let's do the quadratic formula now, because I don't know if doesn't look like it's gonna be a nice number for factoring. So that is -b plus or minus square root b squared minus 4ac all over 2a. You could also just plug this into Desmos and find it that way. That would probably save us a little bit of time, but we're okay. So -b is going to be a -8 plus or minus square root 8 squared minus 4 times 2 times c, which is 5 all over 2 times 2. Got 64 minus 40. No, 4 times 2 is 8. Yeah, 8 times 5 is yeah. 4. And that's going to be 24 over 4. Just plugging this in the calculator because it's going to give us a decimal number. So one answer. That crosses here instead of there. All right, so it should be -0.775 is one answer. So it really should be crossing here. And then the other one's going to be -8 plus the square root of 24 divided by 4, and it's going to be -8 minus the square root of 24 divided by 4. It's going to be -3.225. So that's going to be 2, 3. Okay, I'm about close on that one. So this is your -0.775, and this is your -3.22. That's pretty close. Guesstimation. So this is how you do your x-intercept, or you can factor it if it's factorable. Questions, or you can plug in Desmos and find it. I didn't talk about a couple other things with this. So, well, does everybody have the same, still writing? Oh, wait a minute. So x-intercept, I didn't write that up here. X-intercept is -0.775 and -3.225. All right, the last two things that I want to mention that we haven't talked about. Can you tell me the domain of this? What is the domain of this? Reading it from left to right, what values of x are being covered? From left to right, what is being covered? There's a lot of domain questions on your test. Negative affinity, positive. Thank you, Casey. So look, what does this arrow mean? This arrow means it's going to keep going to the left and up. What does this arrow mean? It's going to keep going to the right and up. So that means your domain is going to be from negative infinity to positive Just about all quadratics are gonna be that, okay? Now, the last thing I want to talk about is where is it increasing and decreasing? Where is it increasing and decreasing? When you're talking about these, you're talking about the x intervals. You have to use the x intervals to describe this. Okay, so look at, this is, you read from left to right. From the left to here, what is it doing? Reading from left to right. It's decreasing. And then it hits this vertex, and then what does it do?
It increases.
And it increases. So how would I write this? Well, from left to here is decreasing. We use the x intervals. So from, what does the left mean? This arrow means it's going to keep going that way forever and ever and ever. So it is decreasing from negative infinity to where on the x value? Negative 2. We would just write the x, okay? And I'm going to close that in. And then we said it was increasing. And again, I'm going to draw this here. We're going from here to here. And again, this is an arrow, so that means negative infinity. You're going from here to here. X value only from negative 2. And then from negative 2 up is increasing. And that would be what? Positive infinity. Okay, that's how you describe increase and decreasing. So you're going to go from positive, negative 2, not positive, from negative 2 to positive infinity. And you're always going to have parentheses around your infinities because that means they go on forever and ever. I think that was something we kind of skipped in chapter 3, but I wanted to go back over it again because it's on your test. So that's pretty much everything with a quadratic, going back over everything. Now, I did want to give you guys the vertex form and just mention that for a second. Does everybody have this? So again, somewhere y'all need to write in your notes, when you're describing increasing and decreasing, you have to use the x intervals. You have to use the x numbers, okay? Somewhere that's going to be on your test. There's a problem that talks about increasing and decreasing and describing it. You're looking at your x, like as you go across, using the x intervals. I promise you have a test on this. I got this? All right, vertex form looks like this is a little bit different. And when it's in a form like this, it's easily, you're more easily able to pick out what the vertex is. You can also pick out your y-intercept, but, yeah. What else can you pick out? The A value is still the same. Y-intercept is still the same, except it's a K value instead of a C. So on this, the positive HK value is your vertex. People forget that. So you have to pull out the opposite here. It's the opposite sign. And then your K value is your, the other part of your vertex. So for example, if I gave you guys negative 2x plus 3 squared plus 1, what would the vertex here be?
Negative 3, 1.
Negative 3, 1, good. You could then multiply it all the way out. So this is not going to be, the y-intercept is going to be different because it's not the same value. Because think about it, if you multiply this all out, you would end up getting a 9 here, and then you would have to add that 1, it would change the y-intercept. Now you could plug in a 0 into it and find it that way. So to find the y-intercept, remember x is equal to 0, you would do negative 2 times 0 plus 3 squared plus 1. That would be 9 times negative 2 plus 1. I forgot about the negative 2 there.
That would be -18 plus 1, which would be, -17 would be your y intercept. When I was multiplying earlier, I forgot the -2. But I like other form better because you can just see a lot more from it. But I do want you guys to be able to at least pick out the vertex from this. And then if you wanted to multiply it all the way out and do it the other way, you can do it that way too. I don't really have time to do another one, but at least I have covered everything from this section, 4.3. So that way, if you do, look over the folder notes on 4.2 and 4.3 this weekend. And then if y'all want to go ahead and at least get one of those quizzes done, or at least a chapter 3 test done, you can go ahead and get that done. So you don't have so much to cover, by Tuesday. So again, I would go ahead and get your notes all written out. Did y'all print out the transformation piecewise sheet? Print those out from chapter 3, have all your notes ready to go before you do your test. And then, go ahead and do your chapter 3 test this weekend. And if you wanted to go ahead and do 4.2 and 4.3, you could. But you could wait on that if you wanted to. Any questions? We're gonna stop about 3 minutes early today since I don't have time to do another question. Okay, I will see you guys on Tuesday.